So, let us take a 1D example. So, one dimensional. Okay. So, the solution will be of the form e to the j. So, let us say something like this. Okay. So, one dimensional wave going, which direction is this wave traveling in? Right. So, along z, plus minus z, whatever, along the z direction is going. Okay. So, now what do I have to do? I have to use those operators which I have defined and use the two Maxwell's equations. Okay. So, the first equation will be, for example, curl of E. This is the first equation that I use. Okay. Now, I write down this curl of E operator, right. So, x hat, y hat. So, I will just write it once for clarity. So, 1 by Ex, 1 by Ey, 1 by Ez, and then here what do I write? Ex, the x, this is my Ex component, right, 0, 0. Which component survives from here? Right. So, only the y hat direction, y hat component is going to survive, and its value is going to be 1 by Ez, correct, del by del z of Ex, right, and that can further be simplified as, there is a z component, no, because d by dy of Ex is 0, right. So, this is just going to give me a j k z by Ez e to the j k z z y hat. Okay. And I know that this is going to be equal to, by Maxwell's equations, curl of E is equal to minus j omega mu h. So, my, as expected, electric field is along x hat, magnetic field is along y hat. Okay. So, the y component can be written therefore as minus k z by E z e to the j k z z divided by omega mu, that is the y component of magnetic field. Right. Then what should I do? If I want one more relation, I need to use the second Maxwell's equation, right. So, I need to plug this into, this is where I will get now a relation between the E's and the H's, small e's and the small h's when I use this relation. Okay. So, again x hat, y hat, z hat, right, 1 by hx, 1 by hy, 1 by hz, and what components do I have? 0, hy, 0. Okay. What component survives from here? Right. So, I am going to get a minus x hat followed by 1 by h z dh by dz. Okay. So, let us just we already have an expression for hy. So, we will just substitute it over here. So, I am going to get a plus j kz squared by hz, Ez now finally comes omega mu e to the j kzz along x hat. Okay. So, I just substituted the value of hy that I already had, that gave me a plus jkz, right, and Hy already had a kz, so it became kz squared. Omega mu was in the denominator, hz ez, right. So, the algebra is fine. So, this is curl of H. What do I relate this to? Right, this whole thing should be by Maxwell's equations equal to j omega epsilon E, which is j omega epsilon, and E is my e to the j k z z x hat, right. So, all this simple hard work, there is not much to it, right. I just redefined del, that is all that I did. So, if I compare these two things over here, what everything, I mean a lot of terms cancel off. For example, the exponential cancels off, the j cancels off, anything else cancels off? No, right. I get a kz squared, denominator is going to be my hz ez. Let me take the rest of the terms on the other side. I am going to get a omega squared mu epsilon, and mu epsilon can be related to speed of light, 1 by c squared, right. So, this is omega by c whole squared, right. Earlier what was our dispersion, this is like a dispersion relation, a relation between wave vector and frequency is dispersion relation. In plane free space, what was the relation? K is equal to omega by c. Now, what is the dispersion relation? Right. So, this is now giving me a dispersion relation of the form that kz is equal to square root of hz ez omega by c. So, what has effectively happened? I have got a new dispersion relation, let us just say that, right. The relation between wave vector and frequency is now altered by some factor, right. So, this is a you can say that this has no relevance to physical reality, because in physical reality Ex, Ey, Ez are all 1, right. At least what we can say is that what we have derived is consistent, right. Now, let's stick to this equation over here, and omega by c whole squared, right, that is going to remain over here. Now, let us go to 3D. Okay, what we did was in a 1D case where there was only one hz, but in general there will be one kz, right, that is a wave in one direction, but in general there can be a kx, ky, kz, right. This is a wave in 3D. Okay. So, then what happens? So, without doing the math, what do you intuitively expect? Equation 1. So, we will have omega by c whole squared will appear always, right. So, I will have a omega by c whole squared, right. In the case of 1D, this was kz squared by Ez hz. What do you expect will happen? What happens in under root, yeah, okay. So, when there was no coordinate stretching, what happened? This became kz squared plus kx square plus ky square. What will happen now? Exactly. So, I will get now k y squared, it should get divided by Ey hy, and I will get a kx squared divided by Ex hx, right. So, I mean you can go and derive it, but you can see that this is the expression that you will get, right. So, this we will call this our equation 2, right, and this omega by c whole squared is what we called the sort of free space k naught square, right. This was from physics, k naught was omega by c, but now we are saying that, oh, this is actually, this is the new expression that we are getting. Okay. So, the other two Maxwell's equations that, I mean the first two Maxwell's equations that I had, right, this one, curl of E, let us go back further, right. So, this expression and this expression, supposing I substitute the in terms of this new waves that we have got, what do we get? So, you will get Ke cross E, right. Actually, before that, let me do the following. Let me define. You notice that this Kx is always coming with Ex and Hx in the denominator, right. So, let me define two new wave vectors. So, Ke corresponding to the E part and a Kh corresponding to the H part. So, what I do is I define this as Kx by Ex, Ky by Ey, Kz by Ez, and Kh I will define as same way, Kx by Hx, Ky by Hy, Kz by Hz. I am only introducing these two to make the math a little bit more So, when I put these two together, can I rewrite equation 2? Does it look like the dot product of something and something? The dot product of these two wave vectors, right. So, that was the motivation behind this. So, omega by c whole squared now becomes Ke dot Kh, just a simplification, right. And your first equation that I had, the curl of E, this gets translated into, remember when I have a plane wave, the curl gets replaced by Jk vector, right. We have seen this, a simplification. So, this simply will become Ke cross E is equal to minus omega mu h, the j gets cancelled. The second equation, curl H, therefore gets translated as Kh cross H is equal to omega epsilon E. Okay. You notice that Kh has exactly the Hx, Hy, Hz terms. So, it is consistent with the definition of del H, and these Ex, Ey, Ez, they are captured in this del E, del E term. Okay. So, I am just in this make believe new world that I have gone into, I am just rewriting all the equations for simplicity. Okay. Now, looking at equation 2, what form of Kx, Ky, Kz do you think I can say is a solution to this? So, let us spend some time interpreting equation 2. So, equation 2 is a 3-dimensional equation in the variables Kx, Ky, Kz, right, and what these Ex, Ey, Ez, all of these are numbers, some numbers that I choose. So, what does equation 2 remind you of? It is an equation of a ellipsoid. This ellipsoid gives me a whole family of Maxwell's equations for different values of E's and H's, and I get back reality, so called physical reality, when that ellipsoid becomes a circle, right, or a sphere over here. So, there is a very simple parametric way of writing down the solution to an ellipse or an ellipsoid if you just use polar coordinates. Okay. So, you may have seen this earlier. So, I can write Kx, you can write it as K naught square root of Ex Hx sin theta cos phi. Okay. So, the radius, I mean the right hand side is my omega by c whole square, which I am calling K naught, right, and square root of Ex Hx is like the length of the semi major axis for that, and the sin theta cos phi. Similarly, Ky I can write as K naught square root of Ey Hy, and what should this be? Sin theta sin phi. Now that you have got the hang of it, this should be Kz should be K naught square root Ez Hz. What should I write here? Cos theta, right. So, this is the solution to 2. Okay. So now this solution actually is what is going to lie at the heart of PML. Okay, so now because it doesn't seem that way, it just seems that we have done some make-believe world where we have introduced some E's and H's and solved this new Maxwell's equations, but let's look at the conclusion, right. So first a bit of notation. So if I set Ex is equal to Hx, Ey is equal to Hy and Ez is equal to Hz, this is called a matched medium. It's just terminology. Having posed the problem in a very general way, now I begin to see where do I want to get to. Okay. So when I make the electrical parameters equal to the magnetic parameters, I call it a matched medium. Okay, that's just a terminology. But the more important conclusion comes over here. Okay. Now all the E's are equal to all the H's. So take any one of these three solutions. Okay. So for example, this solution over here, what will it become? K naught E Z cos theta. That's what it becomes under this matched medium condition, right. And usually we expect these wave vectors. So I mean these are the wave vectors and they correspond to e to the j k dot r. We are used to thinking of k as a combination of three real numbers and that gives me a wave traveling in a particular direction, right. Now the question is this: if we make Ez to be complex, what happens? What happened to my kz, right? So this is my kz for a matched medium. The wave becomes, right. So it will become what? So supposing, so let's say Ez became p plus j q, right. Then a wave which was of the form e to the j k z z will become e to the j. Now kz I replace from here, so this becomes k naught Ez cos theta z, and that becomes e to the j k naught p cos theta z and e to the minus, what else? There won't be any j, the j into j is minus 1, so k naught q cos theta z. What does that mean? It's a decaying wave, right. So this is, in other words, an evanescent wave. So the conclusion, now when I try to interpret from here, my interpretation is coordinate stretching is equivalent to generating or representing an evanescent wave. How? By choosing my E's appropriately. If I chose E's to be some numbers, then I will always get a travelling wave. But if I chose E's to be complex, I am able to get a evanescent wave, right. So this is the connection between the two interpretations, that coordinate stretching is the same as generating evanescent waves. Okay. So this is the, that's why I said that this solution to equation 2, this is at the heart of PML, because by doing a so called coordinate stretching, effectively I am generating a medium where the waves are evanescent. Okay. Further, you can see that in each direction I have independent knobs. In x I have Ex, in y I have Ey, in Z I have Ez, right. So, that corresponds to what? An isotropic propagation, because the propagation constant is different in every direction and I have control over each one of those. So, this is actually a anisotropic lossy medium, right. So, in the very beginning I had mentioned that these are the two interpretations of PML over here. You can see straight away how it is coming, right, and I did not have to deal with tensors or any such things. I got it just by using our usual Maxwell's equations and stretching the coordinates, right. So, this is the principle of PML, the rest are all details. You know, since it is Z, since it is Kz, then it is Z. Where? This equation over here. The second line I wrote x. This is Z still. It looks like x, is it? You mean these two guys? Oh, Z only. Maybe I should write it bigger. The modulus of Ex should be less than 1. Well, it's up to me how to design it. Okay, so good. So, the question is how do we, okay, what we have done so far is we have made the E is equal to H and we have said that E should be complex. The interpretation is of lossy medium. The next question is now, okay, I want more specifics. What value should I set? So, I should look at the reflection coefficient and see how to make it 0, and that itself will tell me what values of E to set. Should the modulus be less than 1, equal to 1, greater than 1. So, we will come to that in subsequent.